We're now going to be talking about the mean of sample means, which is an interesting sounding title. But let's see how it goes. So we're going to start off with kind of actually a warm-up. So I'm going to give some figures for population weight. Maybe this is in pounds. I'm totally making this up. So let's say the mean is 190 and the standard deviation is 12. So we want to know what is the probability of each of these things. So the probability x is less than 190. By the way, just as a point, I didn't pick these numbers randomly. The z-score for this is 0, the z-score for this is -1, and the z-score for this is -2, so we don't have to calculate it too much. That was deliberate. So I want the probability that z is less than 0, and that's just going to be 50%. The probability that x is less than 178 is going to be the probability that z is less than -1, which is 15.87. And then the probability that x is less than 166 is the probability that z is less than -2, which is 2.28%. Okay, nothing that exciting there. Let's keep these numbers in mind though. So we're going to have the same population. So the mean is still 190. The standard deviation is 12. But now what we're going to do is we're going to take 400 guys. We're going to weigh them, and I want to know what is the, and we're going to have the mean weight of that group of 400 people, and then we're going to call it x bar, because it's the mean of the sample. And so the question is, what are the probabilities that the mean? So what's the probability that the average weight of those 400 guys is less than 190? And this is still going to be 50%. I mean, if you take 400 guys, right? So if you think about it, you have your normal distribution curve, and here's the 190. So there's a 50% chance that one person's on this side, one person's on that side. If you have the average group, then there's still about 50% chance that the average of that group is going to be on either side, like that. But let's say the question is, what's the probability that the average is less than 178? So if the average is less than 178, right, there's only about a 16% probability of being in this kind of tail. We call this part the tail of the curve. And for the average to be there, a lot of people have to be there. So it's not, one person there is not enough. The average of the 400 people is going to be there. And so that's actually not going, so before the probability was 15.87, but now it's going to be something less. I mean, we don't know what it is. It's going to be something less than the 15.87%. And to have an average of less than what, so if we're going to take 400 people and, right, only about 2% of the people are in that part of the tail, and to have an average there is going to be, you know, much, much less. Much, much less than 2%, or whatever it was 2.28%. So much, much less than that. So what do we do? So it turns out essentially that, and I'll try to show it kind of graphically, if I could find my great pen. So if the values of x are distributed like this, where this is the mean, if we take the average of a lot of people, what happens is that the average is more likely to be closer to the mean. So the average, so the distribution of averages would look something more like this. So the mean of the sample means is going to be pretty much the same as the mean, But what's going to change is going to be the standard deviation. So instead of having your regular standard deviation, the standard deviation, or how far away it gets from the mean of your sample means, is going to be less. The sample means are going to be closer to the mean. We have a formula for that. And the formula is going to be as follows. So we say that the mean and standard deviation of the sample mean of n measurements, so in the other case that was the 400, is given by, so the mean of our sample means is going to be the same as the mean of the population. That doesn't change, right? The mean of the sample is the same as the mean of this. However, the standard deviation of the sample means is going to be the standard deviation of the population divided by the square root of n. The bigger the sample size, which is n, the closer the data is going to be to the mean.